important things. One thing is quantization, which comes under the basic properties of charges, and second thing is Coulomb's law. Two important topics that we have discussed till now is these two only. So in basic properties of charges, we have talked about three properties: additive nature, quantization, and conservation, in which the numericals can mainly come from quantization. I have even given the worksheet to you where I have told you quantization, how it has to be used in the numericals. Q is equal to NE, and Q is equal to NE based questions comes in 2-3 categories. One category is they will give you a charge and they will ask you find the number of particles. Basic question. 200 coulomb of charge, how many protons are there? So N is required, E is known to you, Q is known to you, divide and get the answer. Second kind of question that comes from quantization is they will say you whether this charge is possible or not. So once again you will check Q is equal to NE and check whether N is a whole number or not. It should be an integer, it should not be a fraction. If it is a fraction, not possible. Third kind of question on quantization is by using mole concept. What they will do, they will say you, they will give a given amount of substance. It can be either an element or it can be water, it can be anything, and they may ask you how much positive charge can be produced by these many number of charged particles. Are you getting my point? They will not give it directly to you, they will give you 100 gram of water. If it is 100 gram of water, by using your mole concept, you have to determine 100 gram of water can contain how many particles, and those molecules can have how many positive charge, and then multiply with E, you will get the value of Q. That kind of question we have done in the class. You can see the video, those who are in the first class. Then we have talked in the last class about Coulomb's law. In Coulomb's law, I have taught you about how Coulomb related the charges, the force between the charges. So I told you, unlike gravitational force, which was only attractive, electrostatic force can be attractive as well as repulsive. If it is like charges, it will repel each other. If it is unlike charges, it will attract each other. So I said to you that the formula which relates these two are very similar to gravitational formula. In gravitation, we studied F is equal to G m1 m2 by r square. In electrostatics, we are studying F is equal to K q1 q2 by r square, where small k is a constant which is medium dependent constant. Its value is 9 into 10 to the power 9, and it is given by 1 by 4 pi epsilon naught. Epsilon naught is called as permittivity of free space. Its value is 8.85 10 to the power minus 12. And then I said you, if two charges are kept at r distance apart in a medium, they have some force of attraction or repulsion. The same charges, if the medium is changed, their force will change, because epsilon naught will become epsilon, and the ratio of the forces between the two charges when they are kept in free space to when they are kept in some medium is known as dielectric constant, also called as relative permittivity. So F naught by Fm is equal to epsilon by epsilon naught is equal to epsilon r is equal to K or kappa, whatever you want to say it. That is called as dielectric constant. So whenever you multiply dielectric constant with the absolute permittivity, that is 8.85 10 to the power minus 12, you get the value of permittivity of that medium. For example, if I say you, a particular medium is having a dielectric constant of 2. What is the permittivity of that medium? Then what you will do, you will multiply 2 with epsilon naught. Then you get the value of epsilon of that medium. Based upon that, the questions may be asked to you. A simple question can be, two charges are placed, force is this much, what is the distance between them? Two charges are placed, distance is this much, how much is the force between them? These kind of questions will never come. Don't expect also. If question comes like this, how it will come, you know? 20 coulomb of charge is divided into two different spheres. Today you solved, no? So if 20 coulomb of charge is there, it is divided in two different spheres. Their force is this much, distance is this much. Find the, anything they may ask you. Each charge, how much it is getting? Like 20 coulomb, it is distributed between two spheres, not equally. Just they told two spheres, and they told distance between them is 1 meter, force between them is 1 Newton, suppose, example. Then what is the ratio of distribution, or what is the net charge on each object in each sphere? What you will do, one charge you will take x, one charge you will take 20 minus x, and then F is known to you. F is equal to K q1 q2 by r square. Q1 becomes x, q2 becomes 20 minus x, solve, get the value of x. It will become a quadratic equation. Solve that quadratic equation, you will get the value of x. This kind of questions are also coming. Then I talked about Coulomb's law in vector form, which is the most important part of yesterday's last class, where I told you numericals will come from here in the board exam also. If the charge is placed at a particular point, for example, I said you, if you have, so suppose you have 3 charges like this, and if I ask you, what is the net force on a particular charge? Whenever you are finding the net force on a charge, please make sure that use the direction wisely. For example, if you have plus q here, and you have plus q here, and you have minus q here, for example, I asked you, and it is an equilateral triangle, then they ask you what is the net force on minus q charge. Then this plus q will attract minus q with suppose force F1. This plus q will attract minus q with suppose force F2. Net force will be in this direction, vectors F net, and value will be root over F1 square plus F2 square plus 2 F1 F2 cos theta. Theta will be 60 degree because it is a equilateral triangle, and then you will get the answer. Mind that this minus q should not be used in F because already you have used a negative sign for finding the direction. So when you're finding F1 value, you should not write kq minus q by r square. Just write kq square by r square. F2 also will become equal to kq square by r square. See, they both are same. So I'll write F. This also will be F. If I am a student, you can do what however you want. So F net will become equal to root over F square plus F square plus 2F square cos 60. So cos 60 is how much? 1 by 2. So it will become root 3f. F is known to you. So the answer is how much? Root 3 times kq square by r square. This kind of questions are coming in the board exam itself. Not that difficult question. If you have the basic idea of vectors, it is a simple question which comes under 3-mark category. Another kind of question, yes, another kind of question can be, they may ask you what is the net force on plus q, this plus q charge. Then this plus q will repel it, this minus q will attract it, the angle between them will become 120 degree, net force will be in this direction, and this net force will become equal to once again root over F1 square plus F2 square plus 2 F1 F2 cos 120. Cos 120 is the most common used ratio in the minus 1 by 2. So here it will be minus 1 by 2, so it will become root of F square, which is F. So net force is going to be F, the answer will be kq square by r square. If you are confident in this big question becomes solved in mouth, not even using pen. Are you getting my point? This question comes, if you are strong in concept, you don't even need pen for solving this, because you know it will be kq square by r square, this will be kq square by r square, and this will be kq square by r, that is f square plus 2f square cos 120 minus 1 by 2 will be make it minus f square. Minus f square will get cancelled, root f square will become f, and f is kq square by r square. I am not teaching anything now, I am revising whatever I have taught in the previous class. Yes?
Sir, can you give an example for like an equal triangular where charge and centroid? Can you give an example?
Yes, last class I did also one question. I will give one more example. Let me solve one question for you. So suppose you have a charge here, you have a charge here, you have a charge here. So in that question that I gave from NCERT book, the net force was 0 because every charge was q, 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 and they have placed a charge q on the centroid of the triangle. Now, whenever this kind of question comes, centroidal question, then you should be very careful about finding the centroidal point. Last class I taught you how to find centroidal point. I said you, when you have a triangle and if it is equilateral triangle, the most easiest way to find centroid is just like, what is centroid? It is a point where all the medians are intersecting. And what are the medians? Which divides the opposite side in equal halves and the angles in equal halves. If it is 60 degree totally, this will become 30 degree, this will become 30 degree. If I draw a line here, it will become L by 2. Now you know it is L by 2, it is 30 degree. Then obviously you can find this distance and this distance also by using trigonometry. Isn't it? Yes, you can take cos theta, cos 30, whatever it comes. So you got the value of this distance, isn't it? If you got the value of this distance, then things becomes child's play for you, because once again this q will repel this q will repel this q will repel this q. Find F1, find F2, find F3, and luckily once again everything will be same because kq square by L by root 3 whole square. And then you solve it, you will get the answer as 0, 0 you will get net Fy because these two will resolve, it will come this side, and this force will be equal, it will be 0. But not always that it will be 0. Don't have a thinking this question comes, I'll write answer as 0 and come. No. Where it is going to be L? Hypotenuse of which will be L, man? Last class you were not there, no, Vinand? Yes. So talk to me after the class gets over. Okay? If you want, if I start solving this now, I will not be able to finish what I thought of finishing today. So those who are absent, those who are not understanding, don't worry, I can separately teach you. Okay? But now let us not stop our today's program. Today my plan is to finish electric field and dipole. Some schools are going very fast. Finish first chapter, exam is upcoming, and then if you don't score well, you will get demotivated. So my aim is to make sure you are ready with the content. Okay? So let us start today's class with all these basic things. Let us start today's class, and today we are going to learn a very interesting topic, a very important topic. If you fail to understand this topic, then this chapter itself will be blank for you, because the chapter, I told you in the first day of the class, this chapter is all about finding electric field only. Ultimately, we are learning Coulomb's force itself to find the electric field. In this chapter, we will find electric field due to a point charge, electric field due to a multiple charges, electric field due to a dipole at axial point, electric field due to dipole at equatorial point, electric field due to a linear charge distribution, electric field due to a surface charge distribution, electric field due to a charged spherical shell. Ultimately, whatever you are going to learn in this chapter is going to end up at electric field only. So until you are knowing what is electric field, how to understand electric field, how to solve the numericals of electric field, this chapter is not in your hand. Okay? Today's class is very important because I am going to give you the basics of electric field, how to solve the numericals coming from electric field. I will even take some board questions which will help you understand how the questions are coming from electric field. Shall I start today's class? With all your permission, I will start. If something is there from last class remaining, you want me to ask something, please feel free. We will have a doubt class from 9 o'clock onwards. Some people can stay back here and ask doubts to me. Some people can stay back in, they should stay back in the online and ask doubts to me. Okay? So let us start today's session of electric field. First, let us understand what is electric field. Today, see, one thing, sorry. Today, I have planned to complete some big topics. So what I want from you, please listen to me very carefully. Today, you don't take much notes. Okay? I will not give time for writing notes much because I want to finish some portions. Today, you listen well, take short notes, hand running notes when I say you to take that. And then, after the class gets over, you can see the video and get the notes. So getting notes is not a problem for you. But now today, let us try to finish some portions today, because some schools are going to have exams in the 10 days. So you should be ready with the first chapter. Okay? So please don't focus on writing. Today you focus more on listening and understanding the concepts. Let us go inside the subject. Yes. So electric field, what is that? So in the 11th standard, you had a chapter called as gravitation, where you learned about gravitational field, right? In 12th, you will have another chapter where you will learn about magnetic field. So what is this field? If I ask you, what is a magnetic field, what will be your answer? Anybody who is there in the class? Just layman's language. A place where the magnetic effect can be felt. Can I say like that? Good, yes. So in layman's language, we can say that magnetic field is the area around a magnet in which its effect can be felt, isn't it? Same way, in layman's language, we can say that area around a charge in which its effect can be felt is called as electric field. But write this in exam, 0 marks they will give you. Okay? It is not the book definition, it is not the technical aspect, but it is true. Electric field means space around the charge where it can affect the other charges. I have a charge here, it can affect till 2 meter, its electric field distance is 2 meter only. So first you write this. Write this. Electric field is defined as the space around a charge. The space around a charge. Electric field is defined as the space around a charge in which it can affect another charge. In which it can affect another charge. It can affect another charge. Please don't write this in the examination. Change the paragraph. Now get the definition what you should write in the examination. Change the paragraph and write what is required for school exams. Write that electric field is defined as force experienced per unit charge. Force experienced per unit charge when it is kept in the vicinity of a given charge. When it is kept in the vicinity of a given charge. When it is kept in the vicinity, vicinity, vicinity of another charge. Okay. Now drop your pens, listen to me. You can add one word where you wrote force experienced per unit charge. Before the charge word, you can add a bracket and write test charge. Okay. You can write a bracket and write test. So it is force experienced per unit test charge. Use the word test there. Okay. Now please understand. If I have a magnet and you want to find its magnetic field, what is the way of finding the magnetic field? You will bring another magnet or a magnetic substance, isn't it? Yeah, magnetic substance only, no? If you have a magnet, you bring wood. Can you find magnetic field? No, right? Either you want to bring a magnet or you want to bring a magnetic substance. Same way, if you have a given charge Q and your aim is to find its electric field, then you must bring a charge, another charge. The another charge that you are bringing to test the charge, electric field of this charge, is known as test charge. Are you getting my point? Please pay attention. I will give time for writing. Please pay, Anshul, please pay attention. Writing is secondary. Listen, understand the concept. Okay? I will repeat it. If you want to find the electric field of a given charge, what do? We take a test charge and bring it in the vicinity of the existing charge. If it is going to be affected by it, then electric field exists. Otherwise, not exist. So what this particular charge will experience a force, that is only known as electric field technically. Yes, I will repeat this. So I said one definition, electric field is defined as force experienced per unit test charge if it is kept in the vicinity of a given charge. Yes, obviously it will be fixed. Because if it is moving, it will also change. It will not move, it will change. The force will change. Because force is distance dependent. F is equal to kq and q2 by r square. If it is a moving charge, r will change, F will change. So whenever we talk about electric field is for a particular point. It is not general. 10 coulomb of charge cannot have a 100 Newton per coulomb of electric field. No. It can have any value based upon its distance. Are you understanding my point? It is not like for a particular charge, it has a given amount of electric field. No. A particular charge is not having any electric field. Electric field is there only for For what? For a fixed distance. Understanding my point? I'll talk further about it. So I said that electric field is defined as force per unit test charge. So obviously electric field is a vector quantity, isn't it? So mathematically all of you can write electric field is equal to F vector by Q naught. And so what will be its SI unit? What will be its SI unit? Newton per coulomb. Its SI unit will be Newton per coulomb, isn't it? So write somewhere it is a vector quantity also. It is a vector quantity. Its SI unit is Newton per coulomb. You can also write this, but I will teach you about this to you later. It is also having another unit, that is volt per meter. In school they may ask, that's why I am telling you. But it will be taught in the coming classes, how it is volt per meter. But electric field can also be defined as volt per meter. Volt per meter. Okay. Now you know very well that between these two charges, suppose distance is r, then what is the force of attraction or repulsion between them? F will become equal to K Q Q naught by r square. And electric field is F by Q naught. So it will become K Q Q naught by r square, and here Q naught will come. Q naught gets cancelled. You get a general formula of electric field which is equal to KQ by r square. This is given as the electric field due to a point charge. I'll give time for writing. Listen. This formula, which is E is equal to KQ by r square, is electric field due to a point charge. It means that if I have 10 coulomb charge, I go 1 meter apart, how much electric field it can produce? K into 10 by 1 square. So 10K. Can I say like this? If I go 2 meter apart, what is the electric field here? K into 10 by 4, 2.5 times of K. If it goes 10 meter apart, K into 10 by 10, it will have only K. K by 10, sorry, yes. K into 10 by 10 square. So K by 10 Newton per coulomb. So you can understand that electric field due to a particular charge is depending on what? On distance, how much away you are going from it. And you can see one more thing. It is reducing as you go away. Can you feel it? Of course you cannot say, because if I have minus 10 coulomb charge, what will happen, you know? Ulta it will become. If I go 1 meter away, so it will become, see, how square of distance only, man? Thambi, minus 10 only, no? Charge only is in negative, no? Distance is in negative. Square root of distance or charge? Yes. So why are you saying the square of it will become positive? We are not going to square minus 10, we are going to square only 1, isn't it? So K into minus 10 by 1 square, how much value will be? Minus 10K. If I go 2 meter apart, how much it will be? Minus 2.5K. Now minus 2.5K minus 10K, which is bigger. Minus 2.5K is bigger. It means it is increasing as you go away. Are you feeling that? So don't think that electric field always decreases in the outward direction. No. Yes, electric field decreases for which charge? Positive charge. But electric field increases for negative charge. Yes, Abhinan, Mr. Abhinan, please. What is mean negative direction, man? Charge is here, it can go anywhere. Don't think it is in axis unit. How can distance be negative, man?
Let's say with vector, let's say there are two, as one particle, one charge, and then two particles.
Then it will become the effect of multiple charges. Yeah. Don't talk about that. Single charge is there. Now tell me, what is the meaning of negative one? Tell me.
Negative one.
The charge. Some charge, 10 coulomb. You are saying no, distance becomes negative. Prove me how a distance can become negative for a single charge. That is your representation, isn't it? Why are you representing minus plus here? It is distance alone I am talking. Whether it is right, left, up, down, towards, away, everything is distance only. And distance can never be negative. Displacement can be negative. Why are you bringing displacement here?
There are more than one particle.
We'll talk about that. We'll talk, that is what you're talking is electric field to multiple charges. We'll talk about that. But now is it clear to you? So before writing this thing, what I have written here, this part, give the heading as electric field due to point charge. This is a topic. After writing electric field definition and writing it as a scalar vector quantity, you please give the heading as electric field due to a point charge and then write these things. Q, Q naught and all these things. Make it fast, please. Hello. Sir, why is he missing today's class, Vaishnav? Okay. Yeah, sir. Ask him to attend. If he is not able to get, let him join immediately online. No problem in that. Huh. Please, sir. I hope you have copied this. Everybody has copied. Can I proceed further? Shall I? Okay. So now you have an idea that if I want to find electric field for a particular charge, it is just kq by r square. Simple. So now how can the question come from here first? Let us go topic by topic. So from here, don't expect the question to come. Charge given, distance given, find electric field. They are not checking your mathematics knowledge. What question will come? I'll tell you. Question will come like, if 10 coulomb of charge is placed, I don't write anything, listen to me. Question, I'll tell you what type of question will come. If 10 coulomb of charge is placed in uniform electric field of 20 Newton per coulomb. You are some other dream. Yeah. Okay, no problem. I'll repeat. If 10 coulomb of charge is placed in uniform electric field of 20 Newton per coulomb. Okay. What would be the acceleration of this charge? Easy only. Those who are understanding for them, easy only. Is the question clear? If a charge of how much? 10 coulomb is placed in, actually not easy man, some data is missing. I'll make it more simple. Let us take a question. All of you take a question now. Kavya, on your camera and take the question. The question is, if a proton, or shall I make it a little more complex? If a deuterium, okay, protium, let it be. If a proton, not protium, proton. If a proton is placed in uniform electric field of 20 Newton per coulomb. 20 Newton per coulomb. What would be its acceleration? What would be its acceleration? Don't take more than a minute. Simple question this is. Make it fast, please. Now, mass of proton, if you are not knowing, then you cannot solve this question. 1.67 in 10 to the power minus 27 kg. You should remember these things. Not required much because in the exam they will give the value to you, but remember, good for you. I am least bothered about the answer. I am more bothered about the way you are solving it. So I hope most of you are solving in the way like,
Did you give 10 coulombs?
I just told one proton
No, the question is for proton placed in unit power.
of 10 Newton per coulomb. Yes. 20 I gave, okay, 20, whatever.
What would be its acceleration? That's all.
Yes. I hope you are doing this. Since electric field is force per unit charge, the force will be electric field multiplied by charge. So what is electric field given? 20. What is charge by one proton? Any, don't write 1. Any is how much? 1. E is how much? 1.6 minus 19. When you solve, you will get the force, this much Newton. And force also is equal to mass into acceleration. So now it is just the multiplication, which I am not willing to check. I hope most of you are knowing how to multiply two numbers. Yes, so it will get cancelled. This will make it how much? 10 to the power minus?
No, not minus, positive. Positive.
It will go up, then it will become positive. No, I'm putting writing down, right?
8.
8. So it will become 20 into 10 to the power whatever. Got it? How much big value can you feel? 10 to the power 8 is more than speed of light, Tambi. Actually, it's not speed, it's acceleration, by the way. It's not speed. That is, speed will be further.
Furthermore,
Yes. So every second,
Second will become that fast.
it is going to increase its velocity by 20 in 10 power 8 meter per second. Imagine how fast this is. So, no, what I am coming to tell, first, all of you have written this? All of you have understood this?
Understood it, but I'm just checking. Let me check it first.
I hope it is clear. Pratap, I hope you are understanding. Very basic question, right?
Yes, sir, I got the answer.
Yes. Anybody has any problem? This Adiba, first class for you. Understanding what is happening?
Yes, sir.
Any problem, please stop me and ask, okay? Don't hesitate. Fine. So now please pay attention. What you are learning by this question? By this question you are learning that if you have an electric field and in that electric field, if you place a charge, that charge will be accelerated. It means it will start moving. Abhinav, not listening? Not listening. Please pay attention. Exam, one day you have to face. Yes, I'll repeat. I said that whenever a charge is placed in electric field, suppose in this room I have electric field. From my right to towards my left, for you it is ulta. From this wall to this wall, electric field is there, like this, uniform electric field. In this electric field, if I place a charge, this charge automatically starts moving towards left. If electric field is from which direction? From your left to right, from my right to left. And positive charge starts moving in the same direction of electric field. Obviously, because formula is this, electric field direction, force direction will be same. So this is the electric field and I am going to place a positive charge it will start accelerating, start moving in the direction of electric field. If I keep a negative charge, it starts moving in the opposite direction. Why is it important, you know? Because when magnetic field will be there, and if I'm going to keep a charged particle in magnetic field, nothing will happen. Nothing will happen. Question will come like this in the board examination. If a stationary charge is placed in a uniform electric field and in uniform magnetic field, how will it differ? In electric field, it will be accelerated. In magnetic field, no force will act on it. But same charge, if it is moving, electric field and magnetic field both will affect it. Because moving charge, I'll come, you'll understand now. A moving charge produces current. You know this? If a charge is at rest, what it produces? Electric field, nothing else. But same charge comes to motion, it produces magnetic field. The moment it produces magnetic, it becomes current. The moment it becomes current, it will produce magnetic field. Magnetic field interact. What will happen? Force will act. Understanding? But a static charge, since it is not producing any current or not producing any magnetic field, it will not be affected by the magnetic field. I'll repeat, some of you are in dreams, yeah.
So the moving charge will affect both electric and magnetic.
Obviously, yes.
Sir, but if it's
Moving charge will not affect, moving charge will be affected by the electric field or magnetic field. Yes.
that and change are in the same direction, sir.
In which case? No, direction will be different. In the case of magnetic field, we have to use Fleming's left hand rule. Intel you studied that. Current direction, magnetic field direction, force direction. It means that if magnetic field have been like this and a charge enters in the same direction, no force will act by the magnetic field. Okay, that's why we are going in that topic. It is a fourth chapter topic. Leave that now. Now, if electric field is there, a charge is there. A static charge itself will start getting accelerated because electric field affects the charge. I hope it is clear. If a static charge is placed in a uniform electric field, it will experience a force. How much force? QE. Got my point? This is one category of question. Another level of question can come. You know how it will come? I'll tell you. Please pay attention. It will come like, if you have two plates, suppose negatively charged plate, suppose positively charged plate. It is in NCERT book also. If there is a positive charge, okay, then this positive charge will tend to make it move in the direction of electric field. This is the direction of electric field, isn't it? It will try to move above, right? Now, because of its mass, it will try to come down. If it is a single charge, then that mass will be very small. It won't be affected by the gravitation. But what if it is a huge mass of charge? A charged body, 10 coulomb charge, big charge, okay? So then the question can be asked like, what should be the value of charge or what should be the value of electric field so that it balances itself? Same position. So downwards, mg will act. Upwards, QE will act. You have to equate both. QE is equal to mg and find the required quantity. This is not an NCERT. NCERT is some other questions there. That is more complex than this. I'll tell about that question also. They'll ask about time taken to come down. That is a different question. I'll talk about that. First, you understanding this? Balancing question can be asked in the examination. Balancing means electric field, a particular charge will be there. They may ask you how much should be the electric field so that it is balancing itself. 2 mark question can come. Is it clear? So nothing has to be done. Find QE, find mg, equate both, get m or e, whatever they're asking to find. Is it clear? Now third category of question from this topic, which is there in NCERT book. That is, let us try to solve it. Take out an NCERT book. I'll open the NCERT book now in the system itself and start talking about question number 1.7, example 1.7. Example 1.7 of your NCERT book. Some of you are not having NCERT book. I'll open NCERT book for you. Don't worry. In internet we can get it, no? NCERT Physics Chapter 1 Class 12 textbook. Book came. Let me download it. Let me open. Yes, book opened. Now those who don't have the book, why like this? Yes. Can directly see the question here on the screen. I am talking about this question. Please don't see the answer. Try to solve by your own way. Understand the question. Leave the answer. Forget about the answer given in the textbook. Very interesting question. It has come in the board exam also. Very interesting question has come in the board examination also. See the question how it is. Please don't write the question and waste your time in that. Listen, read the question and try to solve it. I'll help you at the end of the day. Don't worry. No. Mass of both are same. Electron is lighter. Less time. Lighter, man. We'll talk about that. First, you try solving by yourself. One small thing I want to say you before you start this question. I sent a form in the group to fill your details. What form? Very good. That form is to create an app for you. In that app only we are going to send some video material, study material, attendance. You are still not filling that. Only 10 people have filled till now. Please fill that form by today itself. Then only we can create a login for you. I can take attendance for you. I can upload all the videos there. I can upload all the worksheets there. Please cooperate with us. We have sent a link in the groups. Today itself, everybody, old student, new student, everybody has to fill that form. Then only your login can be created. Fill your parent's number only, not your own number. One number you can put your own also, but one number should be parent number. Okay, Ashwant? Fill the form? Don't know. There in the group? Not minding what we are sending. Let him send. Then what, man? I sent, I tagged, I told, please fill it end of the day, important. Then he is blabbering something. Why you should bother about that? That is only your attitude. Okay, please continue this question. Solve. Fast. They are asking you to find the value, Thambi. Don't talk the. Yes, yes. That you got the idea. I understood. Now solve and get me the value also. Very slow.
Sir,
Yes, please.
so there's a separate equation for object under free form, sir, under gravity.
Okay. Which equation are you talking about? Time period. The time taken to come down.
In the question they asked the time only, sir. So should we equate that
QE.
EQ is 0, Q naught equal to that, sir?
Think, I'll help you. You have to use obviously 11th equations of motion. For sure you have to use. S is equal to U plus UT plus half AT square. V square is equal to U square plus 2S. Anything has to be used only. Take 10. What? Who has stopped you? Whether it bothers now. Shall I talk about the question now? Or you want to try further? You can try. I am happy you are trying. I'll just give you an idea for the question at least. I'll not solve it. Let me give you an idea. Then you can solve further. Please pay attention. Please, everybody, 2 minutes. 2 minutes of your time. Interesting question. You should not make mistake in this. So I am explaining to you what they are asking. Pay attention. They are saying that an electron falls through a distance of 1.5 centimeter in uniform electric field of magnitude. So they have given the value of electric field. They have given the distance from which it falls, and then they are asking the field direction of field is reversed, keeping its magnitude unchanged, and a proton falls over the same distance as in second diagram. Compute the time of fall in each case. So what they are bothered to ask you is, if electron is falling in this electric field, what will be time taken for it to come down? If a proton is falling in this electric field, what will be the time taken for it to come down? That is the question. Is it clear to everybody? Okay. First of all, let us talk about this case now. Electric field is in this direction. Electron will move against the electric field. So obviously electron will try to fall down in this direction, opposite direction. Do you agree with me? If electric field is in the upward direction, then the electron will move in the opposite direction. That's for sure. And they are asking how much time it will take to come down from its. I am assuming it starts from the top of the plate. It's given as 1.5 meter. Okay. So you may say that. Okay, centimeter. You may say that on this charge there are two forces acting. One is QE, one is mg. What I say you, don't consider mg. If you ask me why, I'll tell you why. Later we'll talk about that why. But first let us understand only about QE and solve this question, because when you say that force is equal to Q into E, force also is equal to mass into acceleration. So ma is equal to QE. For electron, Q value is 1.6 10 to the power minus 19. Electric field is given to you. Mass of electron is known to you. You can find acceleration. Do you agree with me? Please pay attention. After that, once again, don't ask me to teach. Listen very carefully. I'll give time for writing. By using this formula, ma is equal to QE, you can easily find acceleration, which will become equal to QE by m. Q is known, E is known, m is known, find A. But they not ask you to find A. If something is falling down, then we can use the equation V is equal to U plus AT. GT I am not using because I am not bothered about gravity now. So if I assume it starts initially at rest, we can use this formula. Or we can use the formula, because we don't have the value of V, so I should not use this formula. V also is not there, no? We can. Why to make it complex? S is equal to UT plus half AT square is the second formula. UT will be 0 because U is 0. This helps me because S is known to me. So from here I will get the value of T as 2S by A root over. Did you agree with me? I hope you agree with me that time period will be root over 2S by A. S known to me, A known to me. Put here, get the value of T. I hope you are getting my point. By solving, we will get. Same way, when the question becomes, for example, here it will become T is equal to root of 2 into S is how much? 1.5 by A. A will be how much? Okay, yeah, take it. 10 to the power minus 2. Okay. And then what will be the denominator? A. A will become equal to Q into E by M. Isn't it? M of what? Electron. M of electron is 9.1 into 10 to the power minus 31 kg. Okay. By that you will find the value of time period. Same way, they are asking what will happen in this case, second scenario. Second scenario, once again, the electric field changed. So electron will, the proton will move in the same direction of electric field. Same equation will be used. You will find time, but the difference will be, time will become in the case of proton as root over 2 into 1.5 by Q E divided by mass of proton, which is going to be different. It will be more. If this is more, this value will be less. If this value will be less, this will be more. So obviously when you solve these two, you will get time taken by the proton will be more than time taken by the electron. That is common sense. Obviously yes, because electron is lighter, it will come down faster. And the values you can find by this formula that I have written on the board. Now, first part of the question is over. Second part they asked, Contrast the situation with that of a free fall under gravity. Now let us assume this is not there. Okay? And it's just a charge of mass of electron is falling under the action of gravity. We know the formula is T is equal to root over 2h by g. 2h by g. Okay? So how much is the value you know? Root over 2 into h. H is how much? 1.5 by g is how much? 9 or 10 you take. So root over 3 by 10. This much seconds it will take to come down. This value will be root over 0.3. Something very small value. This value, you know how much it will be? If you solve it, it will be much more than this. So the effect of gravity can be neglected. I'll repeat it. You have to be in the class. Time taken for a free fall is very small, 0.3 root over. But time taken by the proton without considering the gravity itself is going to be a huge value. See the NCERT book they would have solved. They got the answer as time they got as 1.3 10 to the power minus 7 seconds. Very means very small time. So compare that with this, its effect can be neglected. Are you getting my point? Very fast it will come. Yes.
Sir, I have said that mass of the proton is more than mass of the electron. How will the time of proton be less?
Less I have written more, man.
Can you explain that?
I'll repeat. This formula you are understanding?
Yes.
So it is QE by MP in the denominator. MP is more than ME. If MP is more, this value will be small. If this value is small, this value will be big. It is in the denominator. That's why TP is bigger than TE. Yeah, obviously it is true only. Are you getting why are we neglecting gravity? A little confusing it is, but I will once again explain to you. When you solve by this, if you solve you will realize the answer will come in something into 10 to the power minus 7 seconds, which is 0.000000 something seconds. How much quick it is, right? And here it is root 0.0, something like 0.15 seconds. Not 1.5, actually lesser than that, different value. Around that 0.1 seconds, assume. So 0.1 second it will take if it is falling under the action of gravity. But if it is falling because of electric field, it is taking much less time. That is immediately going. It will not even feel the gravity. Before feeling gravity, it will be down. So why should we consider the gravity? That's why they told that. Contrast situation with that of free fall under gravity. You should say that the time taken for fall due to electric field is very small compared to time taken under the free fall. So it is neglected.
Sir, is it for both or only the electron?
Both. Both obviously.
What is the charge you're saying? It will go up, right?
Yes. Then the story will be different. Then it will not come down. It will go up only. Because gravity's effect is very less.
Yeah. But it is slightly resistive, but it is
Slightly resist. Yes, obviously it will resist. But very small.
very small.
Yes. Is the question clear to you? This question has come long back in the board examination, not recently, long back. I hope it makes sense. If there is doubt, you can ask me later, no problem in that. But you can do this question a little later, not required to do now also. But is the concept clear to you? Here what we have used is, first we have tried to use the equation F is equal to QE. From there we found the acceleration. And then we have used the normal equation of motion, S is equal to ut plus half at square. And we try to find the value of T from here, root over 2s by A. A is known to me, A of electron I have found and found the value of T. Same way A of proton I will find and find the value of T for proton. Got it? You have to be good in calculations in 12th. Have you seen the calculations like how it is going to come? This kind of calculations will only come in 12th. So please practice yourself with more calculations. Anybody has doubt in this question, please ask me. If anybody has doubt in this question, please ask me. Is it clear, Shaktivel?
Yes, sir. But it's not really a doubt, sir, but I'm just asking.
Please.
So the free fall, no sir, it's neglected because the mass is also very small, no sir. Because proton and electrons are very small masses.
Yes, there are small masses. So, do you think in the free fall we are considering the mass first of all? See the formula.
No sir, we're considering.
We are just
No.
considering the height. That's why we cannot say the answer in terms of mass. I hope you are getting my point.
Yes sir, yes sir.
Yes. Understanding, Kavya?
Yes, sir.
Okay. What about you, Varshita Shri? I hope it is clear.
Yes, sir.
Anshul? Kirti, understanding? Adiba, what about you? Is this question clear? Okay, anyhow, you solve it and get the answer at the last. Let us go to the next concept. We are very slow. Next concept is electric field due to multiple charges. Give the heading as. It is also called as principle of superposition. So you know that if there is one charge and you go r distance away from it, the electric field by that charge is going to be kq by r square. But you are not going to deal with one charge. You will have multiple charges. So, for example, if I have a charge here, and if I go r distance away from it, this point, how much is the value of, suppose charge is plus q. How much is electric field here? You can say yes, it is a kq by r square, no problem at all. But what if another charge is there whose value is 3q? Do you think now at this point electric field is going to be only kq by r square? No, because this plus 3q will also exert some electric field here, force here. So it is going to become this plus kq2 by r2 square. But is it just the algebraic addition? No. Because electric field is vector quantity, the net electric field at this point can be calculated only with the vector addition. E vector will become equal to E1 vector plus E2 vector. And I hope you know by now that two quantities, when they are algebraically added and when they are added by vector laws, is not going to give the same result to you. 10 Newton, 5 Newton, if they are added by algebraic, it is 15. By vector, it is root over 10 square plus 5 square plus 2 into 10 into 5 into cos theta. Isn't it? Same way, if I am going to have this kind of question, then at this point you will find electric field due to this plus q charge. How do you find that? By keeping a test charge here. Whenever a question of electric field is going to come in this chapter hereafter, we are going to imagine a test charge and going to keep it at point. We are going to imagine a test charge and we will keep it at point. Usually the test charge is unit positive test charge. It is imagined as unit positive. Unit means its magnitude is 1 and its direction is it's positive. So if I am going to keep this like plus q will repel it, this plus 3q will also repel it. So net electric field will be this direction, E1 square plus E2 square plus 2E1 into cos theta. Very similar to electric force. So if you were clear in the previous class, this will be also simple. Difference is, in the previous class, when I was talking about electric force, I was considering Q1, Q2 and R. Here it will be only Q by R. So for example, I will give an example to you to make it more clear. I may give a question like this, where there is a charge Q, here 2Q, here 2Q and here Q, and it is kept on the square of side A. And then I may ask you, what is the electric field in the center of the square? Yes, so what will happen, see, if I keep a test charge here, which is plus Q naught, then I am going to get this Q as a repelling field. This 2Q as a repelling field. Let it be E1, let it be E2. This Q as repelling field, let it be E3. And this TQ as repelling field, let it be E4. Luckily, since these two Q are same, E1, E3 will cancel each other. KQ by R square, 0. Once again, E2 and E4 will cancel each other, 0. Net electric field here will be 0. Common sense, right? But don't expect the question to be like this. Question will come, they will give you 5Q plus 3Q minus 3Q, and they may ask what is the electric field here at this point. No charge, just the point. Yes.
Can we define coordinates here?
Can we?
Can we like define coordinates here?
You can. Why to make it complex? It's very simple if you don't use coordinate also. If it is 2 meters square, and they may ask you what is the electric field at C, at the point C, what is the electric field is the question. Okay, how can you find? If they are asking you to find electric field here, what will you do?
So we are given that the test charge is at point C and
Exactly. That's all. If you assume test charge is at point C, then this plus 3Q repels, plus 5Q repels, minus 3Q attracts. I'll come one second. This question becomes complex because I have taken random values. So what will happen? First you have to solve this and find a resultant, its angle, then this total angle and find the resultant once again. Huh.
Sir, will you always assume the value of the test charge as positive?
Yes, positive and 1. Okay. So this kind of questions can be asked where they will give you some charges and they will ask you to find net charge at a particular point. What you are going to do? You are going to use vectors. Once again I am repeating, if it is minus 3Q, don't write the value of this electric field as K into minus 3Q by 2 square. No, electric field, this value will become equal to K into 3Q by 2 square. This electric field will become equal to K into 5Q by root 2, that is root over 4 plus 4 is 2 root 2, 2 root 2 square. And this will become equal to K into 3Q, isn't it, by 2 square.
Is it by convention you should use positive?
Yes, by convention only. I hope you are getting my point. One kind of question. I'll solve some question now. Take from NCERT book. Oh wait, I have the book here. NCERT book, come to question number. Yes. Example 1.8. Fast. Please don't take much time. Example 1.8. If you don't have the books in your hand, I have the question for you in the board, on the board.
What are they asking for?
Read the question, man.
C is at point A, B.
C also.
Okay.
Understand the question well. Don't get confused. I hope you are able to understand the question. It's a simple question actually. Equilateral triangle of side 0.1 meter, isn't it? 0.1, 0.1, 0.1. And charge values are having same 10 to the power minus 8 coulombs. And they are asking you to find what is the electric field at different points. First point is between this. It's simple. Don't see diagram and get confused. Do by your own. I hope you are getting what I am trying to tell. Oh, there are two charges only. Yes. So charge Q1, another charge Q2, having a distance of how much? 0.1 meter. And they are asking in center of the charge, what is the electric field? And the value of charge is 10 to the power minus 8 coulomb. Here also 10 to the power minus 8 coulomb. So, negative, why, man? Oh, they told me negative. Okay, okay, okay.
Q2 is negative.
Yes. So minus. So now please pay attention, those who are not understanding. This Q1, if I keep a test charge here, will repel. So I'll write E due to the first charge. Right. This Q2, because of minus charge, will attract in the same direction. It will be E2. So net electric field at this point, at the point B A, net electric field at A will become equal to
E1 is equal to E2.
E1 plus E2. Since they are in same direction, vector also will be having same value, because root over E1 square plus E2 square plus 2 E1 E2 cos 0 will become root over E1 plus E2 the whole square, which will become E1 plus E2 only. So what is the value of E1? E1 will become equal to K into Q1. Q1 is how much? 10 to the power minus 8 by R is how much? Half of this, 0.05 the whole square, plus I said you not to take minus plus sign. In vectors, never take minus sign. So it will become once again K into 10 to the power minus 8 by 0.05 square. Why are we not considering negative sign? Because already negative sign is used for direction. Deva, you are asking something to me? Deva Darshan, you have any doubt? Your mic is unmuted. Okay. So if you find the value of E at A, just double of this. So 2 times of 9 into 10 to the power 9 into 10 to the power minus 8 divided by 0.05 into 0.05, whatever. Solve this, you will get the answer. Got my point?
Yes.
First question is very simple.
Sir, 3.6 into 10 to the power 4 Newton.
Maybe, whatever. Answer is not a problem for me. The concept is fine. This question is clear to everybody? Very simple. Second part, what they asked you, 0.05 meter away from Q1 charge. So I'll redraw a diagram. I'll redraw it on this side, and Q1, Q2 plus 10 to the power minus 8 coulomb minus 10 to the power minus 8 coulomb, and they are asking you to find what is the electric field here, which is 0.05 meter away from Q1 charge, and this is 0.1 meter between them. So Q1 will create electric field here, how much? Repulsive electric field, because positive charge. Q2 will create attractive electric field towards itself. Be very careful, understand these concepts. E1, E2. Which will be more, E1 or E2? E1 will be more. Why it will be more? Because distance is less. KQ by R square. R is small. Electric will be more. So net electric field at this point is B. So net electric field at B will become equal to E1 minus E2. Do you agree with me? Do you agree with me? So E1 you will find E2 you will find and find E1 minus E2, right? Kirti, tell me. Little louder, please, Kirti. The second part, right? Yes, I'll do it. Please pay attention. What I did, they asked us to find what is the electric field 0.05 meter away from the Q1 charge, this charge, right? So what I did, I first found electric field at this point B due to Q1 charge, which will be KQ by R square, KQ1 by R square, which will be repulsive, because if I keep a unit positive test charge here Q naught, this will be repelling it. Positive will repels. Even will be toward, even will be away from this Q1. Q2 is the negative charge. It will attract the positive charge towards itself. So it will be in this direction, E2. E1 will be more than E2. Why? Because distance of E1 is only 0.05. Distance of E2 is 0.15. And electric field is inversely proportional to distance, KQ by R square. So obviously E1 is more than E2. That's why the net electric field is E1 minus E2. Is it clear, Kirti? Okay. So what is E1? E1 will become equal to K into Q. Q is how much? 10 to the power minus 8 by R square. R square is how much? 0.05 square minus K into 10 to the power minus 8 by 0.15 square. Now you have to sit and solve this, no other option you have, and get the answer for second part. Is it clear to you, first and second part? At point A and at point B, how did I find the electric field? Is it clear to you? Sure? I hope. Then comes the third part, part C. For part C, it is little complicated. Why I am saying complicated? See, I am redrawing for you. Let me use black now. So this is Q1, this is Q2, they are 0.1 meter apart, and they are asking you to find the electric field at this point, point C, which is 0. We don't know how much, but from here it is 0.1 meter apart. And from here also it is 0.1 meter apart. So I can say that, you know, to find this value itself, we can say that Q1, if I keep a test charge here, Q1 is how much? 10 to the power minus 8 coulomb. Q2 is how much? Minus 10 to the power minus 8 coulomb. This Q1 will repel at this point, and this Q2 will attract at this point. This is the value of E1, this is the value of E2. Since they are vector quantities having a separation between them, E resultant will become equal to root over E at C will become equal to E1 square plus E2 square plus 2 E1 E2 cos how much? 120 once again. Why 120 came? Because 60 it will become cos 120 degree. Minus 1 by 2, same thing. And both are the same magnitude. E square plus E square minus E square get cancelled, root over E square, root E. So finally the answer is going to be root E, which is root E square. E is how much? K into Q is how much? 10 to the power minus 8 divided by 0.1 square. Solve, you'll get the answer. Simple question it is. Any
9 into 10 cubes, sir.
maybe, whatever. Is it clear to you? Everybody is understanding this? You are dealing with some complex problems of this first chapter. Until you practice, you will not become master in this. Because in exam the same question comes, you should solve in less time. You should not struggle and solve for 20 minutes and get frustrated why I am not getting the answer. So that's the reason we are keeping practice classes, which you are missing just like that. Okay. So if you don't miss the class, only then you will get the practice. And I hope the practice class is useful for you. It is not simply sitting and going. You are coming, solving questions, clearing your doubts and going, isn't it? So don't take practice class lightly. Even the people who are in online live, they are also solving the worksheet, sending to us. I have sent for correction. You will get the corrected worksheet also, and doubts we will be taking from 9 o'clock. So all the practice sessions should be as effective as the regular sessions. Don't play with 12th class. Don't say any reason for missing the class. I miss practice, what will happen? No, it will affect you. It will affect you. Okay? I hope it is clear to you. Is it clear? Next kind of question, how it will come in the examination. Shall I say that also? Shall I go to the next page? Shall I?
Yes, sir.
Yes. So next category of question is, they will ask you what happens, or suppose two charges given, plus 10 coulomb minus 30 coulomb having a distance, or plus 30 coulomb having a distance of 2 meter, and they may ask you at what distance, question is, take the question fast, all of you start solving. At what distance from plus 2 coulomb charge will the electric field be 0? Where 2 coulomb is there, man? It is looking 2 to you, plus 10.
You said 2, I was just listening to you.
I said 2. Sorry. At what distance from plus 10 coulomb charge will the electric field be 0? I'll repeat. At what distance from plus 10 coulomb charge will the electric field be 0? This kind of questions will come. How to solve? You will assume that
E to be 0.
x distance from plus 10 coulomb, the electric field is 0.
That's 2 minus x minus
So this at x point, this plus 10 coulomb will give a repulsive field. This plus 30 coulomb will give a repulsive field, E1, E2. If at this point electric field has to be 0, E1 must be equal to E2. E1 is how much? K into 10 by x square. What is E2? K into 30 by 2 minus x the whole square. K gets cancelled. 10 will make it 3 times. So it will become 2 minus x by x the whole square is 3. And then I will change the question because it is complicated question. I will make the question as plus 90. Okay. Then what will happen? This will become 9.
Yes.
So it will become 3.
Making it
Making easy for you, man. Thank me. So this will become 9. So now it will become 9. So it will be easily becoming 3.
Yeah.
So 2 minus x by x will become 3. And 2 minus x will become 3x. So 2x will become
No, 2 is
4x is equal to 2. X is equal to 1 by 2 meter.
half what?
0.5.
Here.
So 0.5 meter from 10 coulomb charge, the electric field will be 0. Is it clear to you?
Oh, okay, so it will be static then. It can't move there. Charge will stay there.
It means, understand the logic now. It means that if I keep a charge here, it will move. Here it will move. Here it will move. But if you keep exactly at 0.5 meter from plus 10 coulomb, it won't move. It will be static.
Here's the boss, here's the boss.
Cancel.
Static equilibrium.
Something is going inside your head?
Yeah.
Sure?
Yeah.
Now, tell me, man.
Sir, in the question they ask what is the distance from the 10 coulomb voltage, sir?
Yes.
Then there is no need of taking E2.
There is no need of taking E2. Why? I'll tell you why I took C. So from 10 coulomb charge, at this point, plus 10 coulomb will definitely give some electric field here, right? KQ by R square. But since there is a presence of one more charge, that will also give an electric field, right? So how can we neglect it? We cannot neglect it. I hope you are getting my point. And since plus 90 coulomb charge is there, that's why we are able to get net electric field as 0. Understand my point, Deva?
Yes, sir.
If you have only plus 10 coulomb charge, and if I ask you what distance from plus 10 coulomb the electric field will be 0, what will be your answer? You know, infinite. Because electric field formula is K into Q by R square. R will become infinite, E will become 0, isn't it? So the answer is it is impossible to get a point where the electric field will be 0 if it is a single charge. Are you getting my point, Mr. Deva?
Yes, sir.
Because 90 coulomb is there, two electric fields are acting in opposite direction, they are cancelling out each other. Am I right? Something is something you are understanding?
Sir, let's say one is negative, one is positive, it will go attached to this.
Yeah, good question. Now same thing what will happen, I will make a question like 10 coulomb minus 90 coulomb 2 meter. Where is the electric field 0? Is it possible to have electric field 0? Is it possible to have electric field 0? Because whatever point you take, what is going to happen?
One of pushes is going to attract it.
Yes, one thing will push, one thing will attract. If you add them, you cannot get 0.
It cannot be 0.
Do you agree with me?
Yes.
No.
Oh, it will be 0 at that point.
Exactly. Think that, man. What if the why you are taking point between them only? We can take a point x distance like this direction. Now tell me. Plus 10 repels. Minus 90 attracts. Electric field will be 0.
There, okay, yeah.
Possible, no? If it is unlike charges, then the point where the electric field is 0 will lie outside the line. If they are like charges, then the electric field will lie inside the point. Very important thing, very, very important. Board exam questions are coming from here. So, what I am trying to tell you, if this question comes, what will you do? For x distance, first by 10 coulomb, electric field will be this direction, E1. E2 is in the opposite direction, isn't it? Now what will happen here? Yes, E1 must be equal to E2 for electric field to be 0. What is E1? K into 10 by x square is equal to K into minus 90. Why you are taking, man? K into 90 by 2 plus x the whole square. When you solve this question, you will get the value of x. Is it clear to you? These are the different ways how the questions can be asked from electric field. All kind of questions I told you today. From electric field, how the questions can be framed. What is being asked in the board exams. Everything I taught you now. Whatever. I am least bothered about the answer. I am more bothered about the concept. And practice will make you perfect. I hope you are clear in how the questions can come from electric field. Balancing it, time period of fall, different point charges, finding the point where electric field is 0. These are the various places from where the questions are coming in the examination from electric field due to a point charge or multiple charges. Is it clear to you? Sure? Anybody has doubt, please ask me. Anybody? Varshika Shri, you are understanding? Varshita Shri, understanding what is happening?
Yes, sir.
Okay. Here everybody? Mrityunjay, first class. First live class. I'll talk to you after the class gets over. So, what I planned, I could not do. Today my class plan was electric field and electric dipole also. Only half I finished. So now I am announcing, please pay attention everybody. Tomorrow also you will have my class. I will borrow it from chemistry practice class, and tomorrow the class will be from 7:15 p.m. to 9 p.m. a live class happening in the same room. Like this. All the online people. Remember that tomorrow you have extra class of physics, all because of Velamal school, keeping test and giving me deadlines. So I am going to keep a class tomorrow from 7:15 p.m. to 9 p.m. to teach further about electric dipoles and electric field due to electric dipole. That is more important for the examination. Ray optics. I'll talk. Let the class get over. So now the people who have doubts in any kind of question from worksheet or anything can stay back. Others who wants to leave can leave. Now I am going to take the doubts alone for some time from worksheet, from NCERT or anything. So I think from worksheet some people have some doubts. I'll open the worksheet now. So from there you can take the doubts, right? Worksheet opening, I have to send the mail. One second.
Example question, the slide is all.
One second. You came yesterday for the class, practice class. I'll deal with you. Wait.
Sir,
Don't say that. I've added you personal number also.
yeah.